Okay, now this page we're getting into more the nitty-gritty of standard deviation. This is where we have the formula, and it looks scary, but I think the hard part is just remembering what all the symbols mean. It's not like the formula itself is difficult to manipulate or deal with. It's like just so much to remember. You know, if you have a little set of notes, you know, next to you while you're doing your homework or while you're doing your midterm, then it should be all fine. No big deal. Yeah, as long as you remember what the symbols mean, that's all. I think that's the big part of math. What makes math hard is all these symbols. Oh my god, I can't remember all this crap. And then for this math class, you got to remember all what you learned in the previous math class, which is pretty much impossible, but you're expected to anyway. I think that's why math has a reputation that it does. It's hard. That's the reason. Alright, sorry, I'm getting too much into philosophy and stuff like that of math. But I think anyone can do math. It's just a matter of, do I remember everything I've learned previously, and can I use it on a new thing? That's the hard part, really. Anyway, we will not require you to calculate the standard deviation by hand in a checkpoint. So in these little quizzes that we see, or checkpoints, you know, that are between these videos and these pages, we won't be doing it by hand. It's just too difficult. I think in real life, we'll use a program, a computer program, or a calculator, something like that to do it. So why would I make you do it by hand when in real life you would never do it by hand? Instead, we'll use StatCrunch to find the standard deviation. In fact, you already know how to do it. You already know how to do this in StatCrunch because standard deviation is one of the options, along with the mean, median, and quartiles. It's nice. They have all that stuff. Under stats, so you would go to stats, okay, of course, summary stats, columns. So we'll see more on this later, but some students like to know the formulas, so we'll compare and contrast formulas for average deviation from the mean and standard deviation. Yeah, here, for those who like formulas. Those weirdos. No, I'm just kidding. Some people do like formulas, and that's probably a good thing, right? Here is the formula for the standard deviation, followed by the familiar formula for average deviation from the mean. So it might be a good time to... Okay, so here's an example for those who like formulas, which are few and far between, but we'll talk about the formula for the standard deviation, even though you wouldn't have to do it by hand, and, you know, like we said, in this class or real life, whatever. Followed by the familiar formula for average deviation from the mean. So they look similar, you know, you see a lot of the same symbols, but standard deviation, let's see. Notice there's a square root around it, so that, you'd never have to calculate that square root in your brain. You wouldn't have to just say, oh, what's the square root of this number? Because exact square roots we can do, but usually you'll get some kind of decimal number, and no one can do a square root in their head of a decimal number, so it'd just be a calculator thing. And then remember, this symbol means summation. You're adding something together, and what follows will tell you what we're adding together. So in parentheses, that means these are all the values we're adding together. X minus, and X just represents each of the values in your set. Minus, and remember that this X bar stands for the mean. So that might be, you might have written that down before, but just to remember all the meanings of these. So this means summation, or to add. So then what's next to it, they're telling you what to add. Remember, X just means the data values. You're going to range through them, just starting from one, and then moving on to the next, and the next, and the next. You're going to do this calculation, X minus the mean, over and over and over and over until you find all those values. X, the first value minus the mean, the second value minus the mean, the third value minus the mean, on and on and on. You add all those together, and then you divide by n minus 1. So, and then the n being, the n is the number of values that you have in your data set. Values in the data set. And you're hoping it's not too many, because that would mean you would have had to do this subtraction of quite a few times. One value minus the mean, second value minus the mean. So in real life, you would probably calculate the mean first. What's the mean? Add all the values, add all the x values together, divide by the number of values. Okay, once you have that down, then figure out what all these are. X minus the mean for all the data values. Write them down. What's the first data value minus the mean? The second data value minus the mean. On and on until you get all of them. Then you'd add them all together with the summation. And then whatever you get, divide it by the number of data values minus 1. So if you have 12 data values, you divide it by 11. If you have 50 data values, you divide it by 49. Whatever. You'll get probably some decimal number, and then you'll take the square root of that. That's it. All done. As my son would say. He's 2 years old. All done. Now, on the other hand, though, the average deviation from the mean is the summation of almost the same thing. you're looking at, but it's absolute value. So there are no negatives involved here. We would just always get a positive number. The same value as x minus x bar. So you would be kind of doing the same thing. You'd have the mean x bar. You've calculated that. Figure out what all the data values are minus the mean. First data value minus the mean, second, third, on and on. But don't worry about negatives. That's the difference here too. Is the first one, you don't see any absolute values. So some of your answers might be negative. Oh, no, but you're squaring it. I'm sorry. I lost the square. Second power, I'm sorry. So x minus x bar to the second power. When you raise something to the second power, that would make sure it's not negative. So never mind, there would be no negatives here. But I guess to make it a simpler calculation, they just use absolute value in this one. And then instead of dividing by n minus 1, you're just dividing by n. So, okay, what do they say here? Notice that there are similarities between these formulas. Each formula involves calculating the deviation from the mean, okay, like we said. Because the mean is the balancing point from the distribution, the sum of the deviations is always 0. In symbols, the sum of all the x minus x bars is 0 always. Therefore, we have to make all the deviations positive before we add them. So that's done in two different ways. In standard deviation, you square all the differences. You do one data value minus the mean, square that, it'll be positive. The next data value minus the mean, square that, it'll be positive. So the squaring takes care of not, the fact that we don't want any negative values in our answer. For standard deviation, the absolute value takes care of it for average deviation from the mean. Yeah, like I said, with standard deviation, we square the deviations. That'll make sure it's going to be positive. With average deviation from the mean, we take the absolute value of the deviations. Each formula is an average. We add, which is the summation symbol, and then we divide. For standard deviation, we add the squared deviations and then divide by n minus 1. For average deviation from the mean, we add the absolute values of the deviations and divide by n. In both formulas, n is the sample size, so the number of values we have, which is the number of data points. When calculating standard deviation, the final step is to take the square root to compensate for any early squaring of the deviations. Yeah, because when you square here, we were squaring that. Not only does it take care of the negatives, so you won't have any negative values, but it squares the values, so they're going to get much larger than they were before. So, but then when you square root at the end, that kind of makes them all come back down to the right size, closer to the actual data values that you're given. So calculating standard deviation by hand is not fun. I mean, sometimes people have to do it by hand, or it'll kind of help you really understand the formula, so if you want to, it's not a bad idea. But here, if you're interested in it, just because it might give you a deeper understanding, if you do an example, you actually calculate it yourself. Here's a video from Khan Academy. That's a good resource for math. It has math videos of all, from arithmetic to calculus to statistics. But here's one where he calculates standard deviation by hand. And you can kind of follow along if you'd like to. Just that way, you'd really definitely understand these formulas. But we'll never make you do it on these quizzes that we're given after these pages. But in this class, instead of focusing on calculations, we'll focus on estimating and interpreting the standard deviation. So if a computer program or your calculator calculated the standard deviation for you, what would that mean, and what kind of conclusions could you draw from your data based on the standard deviation? We can estimate standard deviation in the same way we estimated average deviation from the mean. Think of standard deviation as roughly equal to average deviation from the mean. So standard deviation is roughly another way of measuring the average distance of data from the mean.